Happy Friday. Hope Debbie has been fun so far. I know we've still got folks trickling in, but we're going to go ahead and get started to keep us on time. So without further ado, I'd like to introduce Baruch Sadogursky, Principal Developer Advocate at Gradle.
Thank you. Thank you. Good morning, everybody. Thank you for coming. I hope you enjoyed the conference. Last day and Friday, I mean, that's a good combo. We're going to talk today about developer experience. Developer experience, also known as developer productivity, also known as DevX, and like one of the hottest topics today. The discussion about developer productivity and developer experience, I would like to start with motivation. Now, usually we think about motivation as like a carrot and a stick combo, right? Motivate people with money, you pay them more, you expect them to do better job, you punish them with fines when you want to discourage them from doing something. And obviously that worked for millennials. This is how people was always motivated, not only people, like animals in general. It turns out that this is not exactly true, especially when it comes to intellectual work. For example, software development. Daniel Pink, one of my all-time favorite authors, wrote an amazing book called Drive, which I really, really recommend. The subtitle of it, The Surprising Truth About What Motivates Us. Since it has a surprise in the title, I will leave you in suspense about what really motivates us and introduce myself in the meanwhile. My name is Baruch Sadogursky. I'm at jbaruch, like on any social media of the week. Developer productivity advocate with a company called Gradle that you might be familiar with as the provider of Gradle build tool, the open source tool. And Gradle build tool was always about making the developers more productive when it comes to their local builds and CI process and what's not. So kind of developer productivity is not a new topic for Gradle. My personal journey, I started as a developer many years ago and then went to the DevOps part of the house with a company called JFrog, and now coming back to development, speaking more about developer productivity engineering. I wrote a couple of books, DevOps tools for Java developers, and the liquid software, and the most important slide of this talk is this. If you go to speaking.jbaruch, you will find there the slides already uploaded, the video that I'm recording right now, and all the links that I'm talking about, including the Drive book and the books that I co-wrote and what's not. Now, to make it easy for you to remember, it's conveniently on the bottom of every slide. You can see there, speaking in Baruch, I don't know what happened to H, but it's there. And you can always go there and remember with the hashtag Developer Week and DPE for Developer Productivity Engineering, coming back to Drive and the surprising truth that motivates us. According to Daniel Pink, the three factors that lead to performance and personal satisfaction are autonomy, mastery, and purpose. Think about it for a second. Node to yourself because it makes perfect sense. And yes, this is what motivates us, all of us, right? We want not to be micromanaged. We want to excel at our jobs, and we want to be part of something bigger. Anyone participated in a project like software project that never went anywhere, just kind of died? Was it fun? Not really. But come on, if you only were motivated by money that you got paid, you didn't get paid less for the project just because it didn't go anywhere. But you were still not as satisfied and motivated. So there is something into it. Now, how it relates to productivity? Well, it relates a lot because in the end of the day, all three of them have something to do with productivity. For example, flow, right? This wonderful, mystical mode that you are in when you are writing code, and you are in the zone, and you are very, very productive. And then autonomy, well, it's time for another meeting, because your boss wants to hear what did you do today. So, or another example, the build takes forever, speaking about Gradle. And I'm distracted to do other things, and then I need to switch context, and it's painful and terrible. Right? Familiar to everyone. Familiar to really everyone. We did a survey in Gradle about developer pains, and 84% agree that too much time spent on waiting on a build and test feedback locally or CI is a really widespread pain. Another kind of very familiar thing, you have a flaky test. And you cannot do anything about it because it's an infrastructural issue. And it's a last in your build suite. It always runs and it ruins your build, right? Something very, very familiar, again, to everybody. 65% will agree with you that it's really, really annoying. Or another problem, everything just feels slower somehow. We have it with our mobile phones, right? It's the same phone, you didn't do anything with it. In 2 years, it's like just super slow for some reason. It happens to our build. The build that was fast a couple of months ago now suddenly feels very, very slow, and you have no idea why. And again, almost 60% will agree with you that it's true. Now, how that relates to autonomy mastery purpose? Well, directly. When you have tools that are not in your way, this goes into autonomy. When you have tools and processes that helps you to excel and do your job better, this goes to purpose. And the word productive has the product in it, which is exactly our purpose that we all want to participate. Now, there are multiple ways to achieve the autonomy, mastery, and purpose. A lot of them is about managerial aspects. How the teams are built, how the teams are run, how the managers perform, but it's also an engineering part of it. And the engineering part of it, it's called developer productivity engineering. Boom. Microsoft PowerPoint has crashed. Speaking about tools in our way, right? It's exactly that. Okay, where were we? We were at developer productivity engineering, right here. Boom, yes. So in developer productivity engineering, when we speak about it, we usually speak about 7 tenets of developer productivity engineering. First, and the most important, is foster faster feedback. It's about fast feedback loops, about less context switching, and about not being disturbed and being able to work autonomously. Eliminate toil for developers, actively eliminating toil that in the way, and by this allowing focus. Collaboration through effective tooling, tools and platforms that promote collaboration, transparency, and shared understanding. Prioritize automation and eliminate bottlenecks. I told you I have a little bit of background in DevOps. This is right from DevOps books. Eliminate bottlenecks and automation. We do it for our production systems. How about we do it for our development environments as well? Embrace rigorous observability for productive improvement. Another one comes from DevOps. We have excellent observability by now on all our production systems, don't we? Yes. Even if you don't admit. It's really embarrassing in 2024 not to have it. So yes, we have it for production systems. Do we have it for our development environments? Not so much. Why? Is it less important that people are productive than our production system are productive? Definitely shouldn't be. So how about implementing observability for that as well? And another one, outcomes over output. Our systems are noisy. Did you ever look at your build log? You did. Did you ever find what you wanted to find there easily and fast? Not so much. have a lot of output, how about having meaningful outcomes out of it? And dedicated organizational mindset. Now, this is very different from DevOps. Well, DevOps, it's obviously on everybody's mind. We just spoke about it. It's natural that everybody invest in our production systems. We need to really force organizations to invest in our development systems as well, and this is what this 7th tenet is about. Now, I want to give you some examples. I have 15 minutes, that's perfect. I want to give you some examples what we can do today in order to implement some of the developer productivity engineering aspects. And even small developer productivity engineering improvements can make a huge difference. For example, using better IDE. And again, this is something that you're like, yeah, obviously, if we use whatever your IDE of choice that you are productive, comparing to text editor that you are not productive, obviously, your developer productivity engineering improves. Testing better, stuff like test containers, stuff like the right testing frameworks can obviously help you excel as well. Enforcing better code, checking for possible errors in development instead of waiting until they get to production or even in CI and then kind of knock you out of your zone of the flow with the context switch when you need to fix something. You can actually make sure that you fix it up front with tools like Sonar. Flaky test detection, I mentioned it. It's a pain that most of you probably familiar with. Again, how about instead of just being frustrating about it and then rerun it until it passes, go ahead, find it, and deal with it. And foster faster feedback, the one that we spoke about. And this is the one that I want to dig a little bit deeper into because it's a little bit less obvious that the others, but it's very, very important. So feedback, what is feedback and what do we expect feedback to be? So we have our IDE, which provides us sub-second feedback. We type something, we typed the name of the variable wrong, it will be immediately obvious that we made a mistake. The feedback is immediate. Build, we did some bulk of code, now we run local build. We expect it to be very fast because we want the feedback and then we want to continue working. And then we have your CI, which is already not as fast, right? You do a pull request, and then you don't really sit and watch the CI running because it might take minutes, maybe tens of minutes. You don't wait for it. And obviously feedback from production, which is also very, very important because, you know, today we do test in production. So we want to hear what is our blast radius, how many of our customers are suffering, but it's definitely not immediate, right? We don't wait for it, but we will get it whenever we will get it. So the interesting part here you can see is if you imagine you're the developer on the left of the diagram and the production systems at the right of the diagram, then you have a reverse dependency on the distance from developers. The further we are from the developer from the left side, the longer feedback takes. And this is kind of unexpected. The reality is kind of close, and I would say the build is the most painful exception out of it. All right? Now, don't take my word for it. If there is an XKCD comic about it, it must be true. And here you go, right? Now, you chuckle because it's a good joke, because you know it's true. Now, it's true for the first time, right? I mean, if the compiling or a local build in our example goes forever every time, no one's going to enjoy it after like first 3 times. It was fun the first 3 times, but then it's definitely not. So yeah, it's funny, we chuckle, but it's not fun. If your build is slow, you're going to suffer. You're going to be more like that. Now, the problem with it is that you are not sure what the problem is. All you know that the build is slow. And that's because modern software builds are a complex software problem which is outside of most people's expertise. Bruce Eckel, one of the really the big figures in the Java ecosystem, who learned Java by their book Thinking in Java? I did. Yeah, a couple of more people, obviously others heard about it. He's a big, a very, very big name. And he wrote a blog post called Problem with Gradle. And obviously the link is right there at Speaking of Baruch. He's speaking about how to do anything, you have to understand everything. Think about it. In order to debug your build, you need to understand how your build works. And this is something that you don't, because it's not your job, it's not your expertise. So not only it's slow and you don't know why. I'm going to solve you this problem in the couple of next minutes. I'm going to explain to you everything that you need to know about build. You won't have the problem that you don't understand build ever again. So what is build? Well, it's project setup. There's something happening and the project is set up. And then it downloads the internet. And then magic happens. It generates artifacts. If it's Java, it compiles. If it's JavaScript, it packages in the zips or whatever tar.gz adds. And then it runs tests. And then the artifacts are ready to be deployed. And then they are deployed to your local machine somewhere. There is some secret directory which is cache. Well, that's all. That's build. Now you know. What can go wrong? Let's talk about how do you debug it. Well, project setup can go wrong, downloading the internet can go wrong, artifact generation can go wrong, tests can go wrong, and artifact deployment can go wrong. So now you know where to look for problems. When can it go wrong? Well, basically at any time. Right, so you understand the build frustrates the developers. This is true, and you probably have been frustrated more than once with your build because it's slow, it breaks, you don't understand what's going on, you don't understand how to fix it, you copy-paste random snippets from Stack Overflow, it makes things even worse. The build frustrates the developers, for sure. Now, what do we do those days instead of Stack Overflow? We go and ask ChatGPT, like, hey, how do I make my build faster? And this is what I did. What techniques can I use to speed up my Maven build? The first idea is skip tests. No, seriously, I mean, skipping the tests defeats the entire purpose of the build. You run local build to get feedback on the code that you just wrote. If you skip the test, you don't know if your code just wrote. So you know what? How about we skip compilation? The build will be faster, for sure. We want faster feedback, but not less feedback. Okay, so what feedback do we want? We obviously want to see if it compiles, we want to see if the tests run, but we can actually look for more feedback. Where do we have the most feedback? The most feedback we have on Twitter, because this is where your customers complain about that your stuff didn't work. But before that, you have a lot of feedback in your CI/CD pipeline. The quality gates that you establish there are should be very comprehensive feedback about the quality of your code, right? Whether it compiles, whether unit test pass, whether integration test path, code coverage, do you have enough? Linting, if your code is up to the standards, static code analysis, again for finding bugs, and then security, dependency scanning, secret scanning, static code analysis for security, and then load testing, resource utilization, compliance. This is a very comprehensive set of feedback that you get, or should I say, can get, from your CI/CD. The problem is that the CI/CD, it's not terrible, definitely, because it's still before your customers suffer, but it's not great because, remember, CI/CD take long time, and you already do something else once you get a notification that your CI failed because you did something wrong, and obviously you will pay with context switch, and you hate it as we spoke. Now, there are two types of feedback, asynchronous feedback and synchronous feedback, and CI/CD is asynchronous. It means that we won't wait for it, but when the results are in, they will be distracting. Synchronous is your local build. If it's fast enough, you will wait for it before doing context switch, and you will be pissed off when it's slow because you just need to sit there and wait for your build, and this is obviously frustrating. The line between synchronous and asynchronous feedback is between the build and the CI. So the build should be synchronous, and the CI is by nature asynchronous. So this amazing amount of content that we gathered in the CI/CD, how about we have it while we wait for it in the synchronous part, in the build? And then you might say, well, but won't it slow the build? Well, it kind of will, because I don't know why. What? It should be two checkboxes. Someone messed with my slides. Anyway, you can pick both. Max feedback. No, seriously, I don't know why that's so weird. Okay, never mind. Both. Seriously. Okay. Both feedback and fast. How do we do it? There are two main avenues of improvement. The first is skip what can be skipped, but no more. You want the tests, but maybe not all the tests, because some of them might be not even relevant. This technique, the avoidance technique, and it's built into most of the modern build tools. It's called incremental build. Incremental build will know that if you already have the jar files from the previous build and your sources didn't change, you probably don't need to compile anything because nothing changed. Now, if you didn't compile anything, you probably shouldn't test anything because nothing changed. Right? This kind of stuff. So you don't build what changed, and you don't build what wasn't affected. If you have a modular system in which you have, for example, an API and an implementation, if you change the implementation module, you don't need to rebuild the API module because it didn't change. On the opposite side, if you change the API module, you still need to run tests in the implementation module because the changes in API might have break your implementation logic. So, avoidance, incremental build now supported in the majority of the build tools. But it's not perfect. It's not perfect because it relies on understanding the produced artifacts. If you ever run like Maven clear build or Gradle clear build, you know that it will build everything from scratch, even if you didn't change anything, because it doesn't know that you didn't change anything, and it relies on architectural decisions. What can be changed, what should be tested, depending on whether you defined your API and implementation correctly. So it's not perfect. What you can do instead? Instead, you can do caching. Caching makes the build faster, but it also makes the build faster for everybody, because caching can be distributed. We can distribute the cache in the team. So even if you build something and I have the same sources, I don't need to rebuild it because I can just take your caches for it. And it makes the build faster always because it relies on the checksums of the tasks to understand whether things are changed or not, and then the results are always in the cache, even if you delete the artifacts and do this kind of stuff. Makes all parts of the build faster because in the end of the day, you can cache anything. As long as you define what are the incomes and what are the outcomes of the task, they can be cached, not only for producing files or this kind of stuff. And you can see here example, and this is a Spring Boot project that we use as an example here for caching. You can see that the build time is 17 minutes, and we actually managed to save 14 as an avoidance from the avoidance techniques. Now, avoidance is both the incremental and the cache. Now, the incremental build is what it's called up to date. It saved 2 minutes, not bad. But the caching, the local and remote, actually saved much more. This what saved actually 12 minutes or the 14. So you can see here how caching is, both avoidance techniques are very, very effective. This is a UI from the Gradle company tool called Velocity, and it actually produces this kind of input, but much more. So yeah, another avoidance technique, predictive test selection. Predictive test selection is a research that was done by Meta ex Facebook, and they said, how about we learn what de facto changes affect what tests. Instead of assuming the logic of, hey, if we didn't touch that, we don't need to run tests, we will actually observe. If we change this, which tests fail, which tests don't fail, and the tests that don't fail, maybe we don't need to run them next time that we make this kind of change. And then we can skip the test with high degree of confidence. So how does it work? We observe what changed and where it changed, and then we correlate with what tests fail because of those changes, and then we can predict what chances of failures will occur. I will give you 2 examples of how the model works. So for example, the more tests a project has, the less those tests break. It makes sense for us, because if there is a good project that has a lot of tests and do a lot of checks, then obviously tests will break less if they do refactoring. The model learned it the hard way. It correlated the changes with the test and came to this conclusion. Even more interesting conclusion, refactorings in Java break tests less than refactoring in JavaScript. For us, it's like, duh, this one is strongly typed. Obviously, the refactorings are more reliable. The model has no idea what we just said. All the model knows that the files that end up with .java, when we change them, produce less test breaks than in files that end up with .js. They don't know why, but they discovered something that makes tons of sense, and this is fascinating. And this is an example, again, a Spring framework, 99.4% of accuracy that the model guesses which tests are not needed. Now, this is a simulation mode. It still runs on all the tests. And this is how we can compare the prediction with the actual results. But if we turn it on now, we are going to save 6 days and 4 hours of potential savings in the last week alone, basically more than one human engineer in a team for a week. This is amazing savings. Now you can say, okay, there are 2 red. It meets 2 tests. Maybe they are very important. If we turn on the model, like in production, 2 tests won't run, but they would fail. How do we do that? Remember, we still have the quality gates in CI/CD that would fix it. Right. The other type of, and I'm out of time, I'm going to run very, very fast and then get out of stage. Give me 2 more minutes. Speed up what cannot be speeded. Test parallelization. Use the max power of local machine. And yes, your boss should buy you the bleeding edge, M2 Pro, Max 3, whatever there is. Because here, we went from 2 minutes to testing to 2 minutes in testing to 2 seconds in testing by using 1 line of code and just using all the APIs. Okay, I'm going to get run out of stage. That is going to be very, very embarrassing. Test distribution is the same for local machine, but done in the cloud. Use that and run all the tests. And with that, with those 2 examples, I'm going to skip to the end and say 84% of people who do developer productivity engineering experience joy. You want to experience joy, do developer productivity engineering, and then AJ Baruch, DPE, Developer Week, speaking AJ Baruch for everything, all the links, everything. Thank you very much. It was supposed to be 24 minutes. I don't know why it ran late. I don't know.
We want to just go over the MOU.
Yeah.
She'll take off your mic and we'll
Yep. Here we go.
This is our computer.
This is your computer, yes.
So I'm gonna pull up the next
Yes,
one.
yes,
Thank
yes.
you, Emily.
Here you go. And here you go. And we're good. And this is mine. And my computer is not here, right? I didn't leave it here.
I don't think so.
Yeah, no, it's over there. I need to turn off the camera.